Assalamualaikum and a very good morning to everyone. I will proceed with the lecture for today, which is for the minimum pre-stress force in consideration of the eccentricity limit. Right, so we can see here we have the maximum practical value for the section. Right, so we need to determine this based on the eccentricity limit. Right, so it is in consideration of the required minimum cover to the pre-stressing tendon. Whereas we have to determine this cover first, right? And this minimum cover, it depends on the exposure and also the structure class and the design, right? So this is almost similar to what we have done in the RC design. Right, so the eccentricity limitation, or E maximum, mainly affects the maximum moments or M maximum action on the section, right? So we have to determine this E max, and then we can determine the value of the M max, right? So as for the equation, right, for the M maximum, it can actually be derived from the equation that we have used previously, which are equations 7 and also equation 8, right? So you can see here we have the load at the pre-stress force that is upper P naught over A, right? And this has to be multiplied by K, which is the factor due to the pre-stressing loss, and so on, right? So we are considering the load at service, right? And since we wanted to determine the value of the moment carrying capacity at the maximum value, right? So we can rearrange this equation, and we can get this M maximum, right? So as you can see here, right, so we have M maximum for two equations, right? So we have for equation 15 and also we have equation 16, right? So from these two equations, actually we can have a linear relationship with between the value of moment maximum and also P naught value, right? So you can see from this equation, it is actually this, as for this M maximum, it is representing the Y value, and as for the P naught value, it is representing the X value in a linear graph, right? So we can see it in the next slide, right? Okay, so later I will show you the graph, with regards to equations 15 and also 16, right? So for example, if we have a beam under sagging moments, we can see here that the Emax value will generally be positive, right? So please do remember, whenever we are mentioning about the eccentricity, it means that we are referring to the location of the tendon, right? So this E value, if I just want to recap back, right? So previously, the E value, when it is moving downwards, from the centroid of our section, therefore we are going to consider the E value as positive. But if the value of E max, or the eccentricity is moving upwards, right, so therefore the value will be positive, right? So those are the sign conventions, right? So I suppose you can refer back to the our previous lecture notes, in order to just recap back and remind you back on the sign conventions that we will be using in the pre-stress concrete design, right? So based on the equation 15, right, so we can see that we are going to have a linear line with a positive slope, with lower limit to P naught. Right, so for most practical cases, right, whereas we have ZT over A minus with E maximum, which is less than 0, it gives lower limit of positive with smaller slope, right? So we can see here, this is the linear graph, for the two equations, right? So we can see this is one equation that is for equation 16, and this is another line, which is for equation 15, right? So we can see that for equation 16, the slope is much more steeper, in comparison, with the slope for equation 15, right? So based on these two equations, right, so if we are solving these two equations simultaneously, right, so we can see that we actually end up with an intersection, an intersection point between these two lines, right? So here, okay, these lines, okay, which actually gives us the maximum moment inequalities, okay, which is satisfied within this zone. Right, so we can see here, okay, this is the intersection, okay, of equation 15 and 16, which gives the maximum economic pre-stress force. Right, so it means that any increase only offers small increase in the moment carrying capacity. Right, so we can see here this is the point. Right, whereas it is most economical, okay, if we are providing, okay, the pre-stress force only up to this point. Right, so here, okay, if we are requiring higher pre-stress force, okay, which is higher here, right, so we can see here that the moment maximum will not move much. Right, so since as for equation 15, okay, the slope, the linear slope is quite shallow. Right, so you can see here that the differences between the difference of the moment maximum is very minimal. Right, so therefore it is much economical, okay, to increase the size of the section, okay, instead of just increasing the pre-stress force. Okay, right, so we can see here these are the relation. Right, so based on the equation that we have derived just now, right, so this is the conclusion that we can make. Right, so next we move on to the example. Right, so just previously I have already explained to you, okay, on how the equations are derived. Right, whereas we have learned how to derive the equations for P naught, okay, and also the equations for moment maximum. Right, okay, so now we are going to go into the example. Right, so as for the structure that we will be referring to, right, so it is of the similar section, okay, as in example 1. Right, whereas we have the span length of 10 meters, right, and also the beam size of 200 times with 350 mm. Right, so previously in example 1, okay, we have already calculated the section modulus, right, and we have also determined or proposed, okay, the beam size to be used for our section. Right, so based on this beam size, we have already calculated ZB and also ZT, okay, which is the value of the section modulus, okay, with regards to the size of beam. Right, okay, so just want to remind you, okay, when we talk about section modulus, okay, the equation is I over Y. Right, so as for this section, okay, that we are referring to for example 2, it is of a rectangular section. Right, so this is the value of the section modulus that has already been calculated for you. Right, so next, we are going to determine the maximum initial pre-stress force P naught required, assuming the maximum eccentricity of 75 mm. Right, so we are not given the value of the P naught value. Right, so but we are required to calculate the P naught, okay, in a relation, okay, to the maximum eccentricity that has been given, which is 75 mm. Right, so first, okay, we start with the calculation of the moment maximum and also moment minimum. Right, okay, so since we already have the size of the beam, right, so we can calculate the self weight of the beam. Right, so similar equation to the RC design, okay, whereas we have 0.2 times 0.35 times with 25. Right, so we have 1.75 kilonewton per meter. Right, so next we will calculate moment maximum and also moment minimum. Right, so when we talk about moment minimum, it means that it only considers the self weight of the beam. Right, so we have 21.9 kilonewton meter. And then for moment maximum, right, so we are going to consider the external load as well. Right, so we have 3 times 10 to the power of 2 divided by 8 and plus with 21.9, okay, which is the self weight of the beam. Right, so now here we have 59.4 kilonewton meter. Right, so we already have calculated M minimum and maximum. Right, so the next step, okay, is to calculate the pre-stress force. So previously, okay, in the derivation of the equations, we have already derived equations 11, 12, 13 and also 14 with the P naught value that is sitting on our left. Right, so we have all these equations and we can calculate for the P naught value at transfer and also at service. Right, so I'm going to show you one example of the calculation. Right, so we start with P naught. Right, so ZT, times with F prime minimum minus with M minimum divided by ZT over A minus with E. Right, so this is the first equation, which is equation 11. Right, so we can substitute all the values. Okay, so we have ZT, then we have F prime minimum, right? Okay, which is the limit, right, at transfer. Okay, so we have the tensile stress limit, which is -1, then minus with 21.9, okay, which is the M minimum that we have calculated earlier. So divide by ZT over A, okay, minus with E. Right, so the value that we have here is 1555 kilonewton, okay, positive. Right, so please do take note here, okay, that for this denominator, right, whereas we have ZT over A minus with E, okay, it gives us a negative value. So when we have a negative value here, what we have to do is that we have to change its sense of inequalities. Right, so you can see here, okay, the basic equation of equation 11 is that P naught is larger or equal to this expression. However, due to the negative value of this denominator, what happens is that we have to change this sense of inequality to less than or similar to the value, right? Okay, so you can see here the difference here. Okay, so this is the original equation, right? Then due to this negative value, so what happens is that the sign has been changed, right? Okay, so please take note on this, right? So there are cases, okay, which actually depends on the value of eccentricity, okay, whereas we are going to have the negative value, right? So please take note on this, okay, because later, okay, when we are required to plot the Magnell diagram, right, so we are going to actually depend, okay, on this sense of inequalities, right? Okay, so this is for the first equation, okay, which is equation 11, right? So that is the change in the sense of inequality, right? Okay, so next we will proceed, okay, with all the calculations, okay, for equations 12, 13, and also 14. So please note, okay, for equation 13 as well, right? So since we also have ZT over A minus with E here, right? So therefore the denominator will be negative, right? So similarly, okay, we are going to have the change, okay, in the sense of inequality in these equations as well. Okay, right, so these are the values, right, which actually gives us the range of pre-stress values, okay, that will be in use to our structure, right? So what is given here, okay, is the values that is given in terms of inequality equations, right? Okay, whereas we are actually given the range, right? So as for this range, okay, in order for you to understand, okay, on which value that we are going to have to use, okay, for our structure, okay, we'll move on to the next slide. Okay, so this is the range of the pre-stress values that we have obtained, right? So based on these values, actually you can draw this range, right? Whereas we can start with 0, okay, then we have the positive values, right, which are positive 557, okay, then we have positive 623 and also positive 1555 kilonewton, right? So those are the positive values. Okay, then we also have one negative value, which is negative 2881, right? Okay, which is on our left, right? So we have the positive values on our right and also the negative value on our left, right? So what you can do here, okay, from the range of pre-stress values, right? So you can actually draw, okay, the range that is covered by each inequality equation, right? So you can see from equation 11, we have P naught is less or equals to 1555, right? So the point of 1555 sits here, right? So it begins here, and all the values that is lesser than that, okay, is considered as fulfilling the first range. Then for the second equation, okay, whereas we have equation 12, so it starts from 623, okay, whereas the value is less or equal to 623, so it goes to the left as well, right? Then as for equation 13, so this is another one, okay, whereas we have P naught is larger than or equal to negative 2881 kilonewton, right? So it starts from negative 288, okay, and it goes to the right, okay, whereas we are going for the larger values, right? Then the next one or the last one is P not larger or equal to 557, right? So as for this one, we can see that the range goes to the right as well, right? So we have 557 here, and for values that is larger than 557, it goes to the right. Okay, so based on these values, so what we are going to do is that we are going to find the how do we say, the intersection, okay, between these ranges, right? So we wanted the range to overlap between each other, okay, in order to decide on the range that we are going to use for our structure. Okay, so as for this example, okay, with regards to these four equations, so we can see that this is the range that we actually wanted, right? So we have 557 and also we have 623, whereas you can see that these lines, okay, all four lines, okay, is bounded, okay, between these two values, right? So you can see here, okay, so this is the range, okay, that we are going to consider, right? So therefore, the range of the minimum value of the pre-stress force is within 557 kilonewton, okay, up to 623 kilonewton, right? So this is the range that we are going to use, right? So therefore, as for the pre-stress force, okay, we are going to choose any values that is in between 557 and 623 kilonewton, right? Understand? Right? So it is as easy as that, right? So this is where, okay, we are going to apply, okay, the inequality equation, right? So inequality equation is actually giving us the values that is in the range, okay, instead of giving one exact value, okay, right? So this is for the range of the pre-stress force. Okay, then the last one, okay, is to check the upper economic limit to the pre-stress force, right? So you can see here again, we are going to use the same limit that we have calculated earlier, right? And here we are going to consider the moment maximum equations, right? Which are equations 15 and also equation 16, right? So these two equations, okay, is actually to determine, okay, which part, okay, or which pre-stress force will give us the most economical design, right? Okay, so we are going to equalize, okay, these two equations together, okay, in order to get one P naught equation, right? Okay, so we are going to equalize here. So we have this 15 equation, this equation 15, okay, on our um, left, okay, and also we have the equation on our right, right? So I suppose I need to do some correction here, okay, because we actually need to have K here, right? So it's KP naught, K times with ZB over A plus with E maximum, right? So this, I have to do some correction here, right? So please take note on this, right? So this is the equation, right? And when we rearrange the equation, so we will get this equation, okay? So we have P naught less or equal to F maximum ZT plus with F minimum over ZB and so on, right? So this is the complete equation, right? So we are going to calculate, and by substituting all the values, right? So and by considering here, right, whereas we have F minimum equals to 0, right? So this part or this expression will be equal to 0, right? So therefore P naught is less or equal to 1050 kilonewton, right? So when we check back, okay, this value is greater than the limit established earlier, right? So therefore, this 557 kilonewton at this range, okay, of between 557 kilonewton, okay, and also 623 range, okay, is acceptable, right? So we can see here that the value P naught that we consider in the calculation or the checking of the upper economic limit, okay, is showing that P naught is supposed to be less than 1050, right? So we can see that our range is within that um, limit, right? Okay, so therefore we can consider that the P naught that we have already calculated is acceptable. Okay, right? So I think that will be the end of our lecture for this week, right? Okay, whereas just want to recap back, right? So I have already explained to you, okay, on the stresses, okay, that we are going to consider, okay, in the design of a pre-stressed concrete structure, okay, whereas we are going to consider the compressive stress and also the tensile stress, right? Then as for the limits, right? So we have the limits, okay, which are maximum limits and also minimum limits, okay, whereas we have to consider the limits at transfer, okay, and also the limits at service, right? So please do remember, okay, the equations in order to calculate these values of stress limits, okay. Then as for the second lesson outcome, right, okay, is that I have already shown you on how to determine the minimum section sizes, right? We have already calculated those, okay, which is based on the minimum section moduli, right, or Z value. So we have rearranged the equation for the pre-stress, for the basic equations for pre-stress force, okay, whereas we rearrange the equation to get the Z value, right? So based on the Z value or the section modulus, okay, we have already determined the suitable section to be used for our design. And the next part, okay, is to determine the pre-stress force, okay, that is to be induced to our section, right? So as we have four equations, okay, and we are going to get the range, okay, and from the range also we are going to calculate which one is the most economical, right, to be used, okay, for our section. Right, so I think it will be all for this week, right? So if you have any questions, okay, so feel free to contact me through Microsoft Teams, or you can also contact me through WhatsApp, okay. So I'm currently trying to develop a channel in the Telegram, okay, and also I'm going to upload all the course materials, okay, in the YouTube channel, right, so that it is much easier for you to download, okay, or view. And in case you have any accessibility problems, okay, feel free to contact me at any time. Okay, right, so thank you and assalamualaikum.